Hi, welcome back to Mr. Slover's Math. Today we're focusing on solving systems of equations by substitution. So recall that a systems of equations is just two straight lines that we're going to see on potentially one graph or not on a graph, and we just solve it. So if you've been following along on the notes or in the lesson, this first page should look pretty familiar because this is the same page that I had for solving systems of linear equations by graphing. I want you to get used to what you're going to see. So there are three different ways to solve these systems. One is by graphing today, which is what this is in here. Today we are going to focus on solving by substitution, which is going to kind of be this part down here. Now we have seen some of this already in the past. Okay, the three different types of solutions that we might see are one solution, which graphically means we have two lines that intersect. No solution, which means graphically we have two lines that are parallel, they're not going to intersect. And we have many solutions, so graphically it's the same line. So that's what we saw previously. But now we're going to focus on solving the equations. So once we solve an equation, how it's going to look after solving. Well, if I have one solution and after I solve my systems, I could get something that says x equals 3 or y equals 4. If I'm solving a system and I end up with no solution, that would look like 7 equals negative 10 after I solve. And you're thinking, well, that's not a true statement. Well, yeah, I agree. That's a false statement. You could also see something that is for many solutions. 3 equals 3. Well, that's a true, right? That's true. You think about it. 3 does equal 3. That's a true statement. So if you see any of these after you solve, here's how you answer. So if I have x equals 3 and y equals 4, that means I have an ordered pair as my solution. It means it's going to intersect at 3, 4. If I have something that is not a true statement, so just like this, not a true statement, I have no solution because I have two lines that are parallel that will never intersect. And if I have something that is a true statement, I have the same line. So some math teachers call it infinitely many solutions or infinite solutions. I'm just going to call it many solutions. But realize that it's the same thing as infinitely many solutions. Okay, I'm just shortening and making it easier to write. So many solutions. Those are the three things potentially that we're going to see the next couple days in our lessons. So this first example is already worked out for you. All you have to do is just pay attention. Okay? So you can reference your notes later. You can go back and work through it, look at it, whatever you want. So you're solving by substitution. Think about substitution. Think about a substitute teacher. What happens when your teacher is gone? Well, you have a different adult in the room that is replacing him or her. But everything else is the same. You're still in the, well, you should be. You should still be in the same room. You should be sitting in the same desk. The same people are in your class unless they're absent. Everything's the same except that one aspect, and that's your teacher. And that's the same thing with solving systems of equations by substitution. The only thing changing is one aspect. So in this case, I have x equals this. I'm going to take what I highlighted and I'm going to substitute that in where I see the letter x. That is the only thing changing. Okay, everything else is still staying the same. I still have a 5. I still have the plus 2y, the equals, and the negative 4. All of that is still the same. The only thing changing is the x, and that's why I highlighted it. From there, I'm solving. So I need to distribute. 5 times 2y is 10y. 5 times negative 8 is negative 40. And then I still have the 2y, the equals, and the negative 4. From there, I'm just going through and I'm solving. I'm collecting like terms. 10y and 2y give me 12y. And the negative 40 is there. I'm going to add 40 to both sides. And then I'm going to divide by 12. I get x equals 3. Now, lots of students like to think they're done because they solved. Y equals 3, I'm done, got it. But go back and look. There's actually two variables in this equation. There is an x and a y. So we solved for y, but we did not solve for x yet. So we need to take y as 3 and we need to plug it in to solve for y. Or sorry, to solve for x. I am choosing to plug it into this equation. The x equals 2y minus 8. It doesn't matter, but to me this one looks way easier to solve. So I plug in y equals 3. So x equals 2 times, instead of y, I'm plugging in a 3. I'm substituting in a 3 minus 8. So then I do 2 times 3, which is 6. I'm following that order of operations. Then I'm going to subtract 8. So x equals negative 2. So I have y equals 3, x equals negative 2. So that means I have two lines. These two lines intersect at negative 2 comma 3. Well, I need to write that as my ordered pair. That's my solution. If I were to graph these, they would intersect at this point. If I were to plug in negative 2 for x and 3 for y into both equations, it would make them both true. Okay, that's why it's my solution. Now you may be thinking there's got to be an easier way, and there's really not an easier way, but I did come up with some steps that might help you. So it says solve the systems of equations using substitution. Here's our steps for success. Solve one equation for x or y. So if it's not solved for x or y, you need to do that. And so you want x by itself, or in this case, y all by itself, which just means y is on one side of the equal sign with a coefficient of 1, and everything else is on the other side of the equal sign. Once that's done, you're going to plug the answer from step 1 into the other equation. So I'm taking this 6x minus 11 and I'm plugging it into the other equation. And then I'm solving for that variable. So we're back to what you did in like freshman year, multi-step equations. So I'm distributing a negative 3. Right? That says negative 3. You may think, well, it says minus 3. Well, you can change that minus to a plus negative. That is okay. Laws of mathematics say you can do that. A minus 3 is the same as a plus negative. So I distribute the negative 3. I end up with negative 18x plus 33. I highlighted my like terms and I combined them. And then once again, I'm just working through solving the equation and I get x equals 2. Step 3 done. Step 4, plug the answer from step 3 into one of the equations and solve for the remaining variable. It doesn't matter which equation you choose. I like to always tell people choose the one that looks the easiest. X equals 2. Well, this top equation looks way easier to solve for y. So y equals 6 times 2, and we know what x is. We're substituting that in. 6 times 2 minus 11. So I get 12 minus 11. Y is 1. So I completed step 4. And now I'm at step 5 where it says write your solution. So my solution in this case is an ordered pair of 2 comma 1. So these two lines intersect at 2, 1 on a graph. If I weren't to graph them, x is 2, y is 1. I plug it into both equations. It makes them both true. That's my solution to my system. So there's example 2. And then here's just some more examples. I do, though, want to talk about example B for 2 reasons. Number 1, I need to do something different with step 1 and then what my answer looks like. So it says solve one equation for x or y. So if I look here, neither of these are solved for x or y, meaning I don't have x with a coefficient of 1 on one side of the equal sign and everything on the other side, or I don't have y with a coefficient of 1 on one side of the equal sign and everything on the other side. So I need to fix that. Well, in order to do that, it's easier. You can solve either equation, but it's easier to solve the bottom equation for y. All I got to do is add x to both sides. This is just a negative x term. I want to get rid of it. It's like I owe someone $1, right? X could represent $1. Well, I give them $1, so they cancel it out. So I'm adding to it. And then on the right side, 3 plus x is not like terms. They're not the same. One is a constant, one is a variable. They are different, they stay separate. So now that I have y equals all by itself and everything's on the other side, my coefficient is 1. The variable's all by itself on one side of the equal sign, everything's on the other. Now I can go to step 2 where I plug it in. Okay. When I plug it in and I distribute the 3, I get negative 3x plus 9 equals 4. Well, this negative 3x plus 3x reduces to 0. Don't put in an x. Don't think you did something wrong because you got 0. It is okay to get 0. Negative 3x plus 3x. I had $3. I spent $3. It's gone. 0. But I'm left with the 9. And I didn't do anything to the other side of the equal sign. So now I look at this and it says 9 equals 4. That's not true. 9 does not equal 4. Well, if it's not a true statement, my solution is there is none. There's no solution. Because these two lines are parallel. If you were to graph them, you would see that there's two lines that are parallel that do not intersect. So there's no solution. So the steps for success would be your best bet on making sure you're doing everything right. The best way to get better at these, just like with any math, is to practice.